Hey, it's Justin with Lesser Dog Tutorials, and welcome to episode 2 of the point-and-click adventure game tutorial series. So, to kick things off, I want to revisit the C++ script we did last time real quick. So you just go to File, and then open Visual Studio Code. And I added a few lines in here, and it's mainly just to prevent crashes. So all you have to do is add a few lines. So make sure that your code looks like mine. And I'll kind of go over briefly what I did. So for the getWorld function, I just made a variable called ourWorld. And I made sure to put that asterisk on uWorld up here. And then I checked to see after that if it was valid. So you can see that it's an if statement. And in the if statement, parentheses, it says our world with an exclamation point before it. So it basically says if our world is not valid, then it will return out of the function and we will not read the lines that are following. And then I use the our world in the next line instead of get world because we've already determined it's valid. Then I move on to the screen layout stuff. And then I say the viewport, because I'm about to use the viewport next, so I check to see if that also is not valid, and if it's not valid, I return. And if it is valid, it moves on to the next lines. So the return, the if statement with the return is just saying, hey, if this pointer is not valid, get out of here. Because if you don't do that and the pointer variable is null, it will crash the editor. So when that's done, make sure you compile. And then we're ready to move on. Okay, oh my wordy McTurdy, we have a lot to go through, so let's roll through. I'm going to go kind of quick, hopefully you can follow. Remember, you can pause at any time, so if this is going too fast, you can slow down the video too if you want. So in the character blueprint, pull out the character movement, get the velocity from that, and then check the vector length. And make sure it's above 0, and if it is, guess what? Character's moving. This is our little character movement check. We can collapse to a macro, and we'll just call it is character moving. And then we'll add one input and two outputs, and they're all going to be exec pins. And the two outputs are just going to be yes and no, and the input I just named in. And just connect up the branch to the inputs and outputs. And now we have that, which is going to be useful. And we'll plug that in at the end of the simple move to location. So each tick, we're just going to check, hey, is the character moving or not? Then we'll add a new variable. We'll call it x speed. And we'll add another one called y speed. And both of these will be floats. And then create another macro that we'll call set speed. Add the in and out pins. And then drag in x and y, and we're going to set them. And then if you drag in the character movement, we'll get the velocity. And then add a get actor rotation node. And from the velocity, drag out and do unrotate vector and connect up the actor rotation and the velocity. Split the struct pin of the right side, the output of the unrotate vector, and connect x and y to the x speed and y speed. All right, now add another variable that we'll call idle up. And this is going to be of a type flipbook, paper flipbook. And so we're just going to be making the different animations that we need for our character. So make an idle up, idle down, idle side, and drag those into its own category called flipbooks, which just cleans things up a bit. And then we can add the walking animation, so walk side, walk up, walk down. Drag those into the flipbooks category also. And then we can set the default value to the animations that we made in the first video. And then go to the blueprints folder and make a new enumeration that we'll call enum underscore current anim state. And then make another enumeration called enum underscore moving direction. And then you can open those up because we're going to have to fill in the information inside them. And so for the current anim state, we need one for each of the animations, so 6 total. And that's idle side, idle down, idle up, walk side, walk up, walk down. And then you can save that and close it. And then for the moving direction, we're just going to make 4, which is essentially going to be not moving, is going to be the first one, and then moving side, moving up, or moving down. We don't need to differentiate the right and left because that's just going to be flipping the rotation of the character. Now create a new variable called current animation state and set it to the enum current anim state type, and then create one for the moving direction and set it to its enum moving direction type. Drag in set speed and attach that to the is character moving yes output pin, and then create a new macro that we'll call get primary direction. And then we're going to have an in pin, but then the output is going to be 2 exec pins. One's called horizontal and one's called vertical. Bring in the X and Y speeds and convert them to absolute floats just so that we can make it not negative and just make them both positive. And we'll just see if the X speed is greater than the Y speed. And if it is, that means that they're moving horizontal. And if it's false, they're moving vertical. And then if you drag in the get primary direction macro, you can attach it to the out pin in the set speed macro. Next, create another macro and call it set animation state. And it's going to have the in exec pin, but also an anim state pin of type current anim state. And then the output pin will just be an out exec pin. And then drag in the current animation state and set it at the beginning. And then add a node for set flipbook for the sprite. Connect that in between the output and the set animation state. And then add a select node. The return value will go to the new flipbook input pin of the set flipbook. Drag in the current animation state, connect it to the index of the select node. And then we're going to connect each of these flipbook variables to their corresponding slot in the select node. And compile and save that, and we're done in there. Next, create another macro that we'll call set horizontal animation. Add the in pin and the out pin. And we'll duplicate that and we'll name the new one set vertical animation. So in the set horizontal animation, we're going to bring in the X speed. And from that, we're going to compare the float. And we're going to compare it to 0. And then we're going to add a set relative scale for the sprite. And then duplicate it. And then if X speed is greater than 0, it goes to the top one. If it's less than 0, it goes to the bottom. And then set all the numbers to 1, except the X value on the bottom one, set that to -1. And then both of them will connect to the set animation state macro we made earlier. Just make sure the anim state is walking side. And then after that, we're going to set the moving direction to side and connect that node to the output. Then you can compile and save and switch over to the set vertical animation. And so the first thing in this is the set relative scale for the sprite again. Then set all the numbers to 1, and what this will do is just reset its rotation if it was flipped. And after that, we'll do a compare float, and we're going to compare the Y speed to 0. And then you can drag in the set animation state macro and connect it to the top the greater than output, and then we can duplicate it and connect it to the less than. So the top one animation state will be walking down and the bottom one will be walking up. And then after that, each one we're setting the moving direction to its corresponding animation state. Just make sure they match up. And then both of these will connect to the output. And we're done with this macro too. So back over in the event graph, drag in the set horizontal animation and set vertical animation and connect them to the corresponding pins on the get primary direction macro. Now, from the set horizontal animation and set vertical animation, just have them connect to a reroute node, and then we'll add a do once node and connect them to the reset input pin. And then we're going to add another macro called set player position. And we'll add the input and output pins as per usual. And then drag out from the input pin and search for the set target player location variable. And then split the struct pin. Bring in the capsule component, and then we're going to get the world location and also split that struct pin. And then from the X and the Y value, what we're going to do is use the floor node just to make it snap to the pixel. And this is only really useful for pixel art, like what we're using in this. And that way, anywhere the character moves, he's going to stop in line with all of the pixels in the background. Then connect the Z value straight to the player location, because that will never really change. And then right-click and get the world location for the capsule component and tack that onto the end of the set player location, and then connect it to the out, and we're done here. But head over to the set horizontal animation if you didn't connect the sprite to the bottom relative scale node. Make sure you do that. Then back in the event graph, drag in the set player position and put it at the end of the do once node. Alright, so now let's make a new macro called determine idle direction. This is just going to see which way the character is going to be facing when he stops, depending on which way he's moving. And at the beginning, let's pull out from the in, and we'll do a switch for the enum that we made earlier called moving direction. Drag in the moving direction variable. That's going to be the selection. And then bring in the set animation state, and we'll duplicate that twice so that we have 3 of them. Top one will be idle side, and the middle one will be idle up, and the bottom will be idle down. Then you connect them up to the enum node, and then make sure that the set moving direction is after the set animation state, and it's set to not moving. Then back in the event graph, after is character moving on the no output, we put determine idle direction, and then connect that up to the do once node. And then we should be now good with testing out the animation. And it is working, it's just a little fast, so let's just tweak something in the character movement component. It's the walk speed, max walk speed. We'll switch it to 80. See how that works? There we go. That looks good. And so now he should be stopping in the correct facing direction. He should be walking with the correct animation. And if he's going vertically more than he's going horizontally, then it will use the correct animation for walking up or down. Cool. Now we need to work on figuring out how the UI looks, so we can mock that up real quick. Well, not quick, but we'll mock it up. So in the blueprints folder, we'll make a new folder that we'll call widgets. And in there, right click and go to user interface at the bottom and select widget blueprint. And we'll name this WBP for widget blueprint _ HUD. And we'll go ahead and open that. So on the top right, instead of fill screen, we'll do custom, and then we'll set the width to 320 and the height to 200. Then on the left in the palette, we'll search for vertical box, and we'll drag that under the canvas panel. And then right click the canvas panel and do replace with child. And then we're going to right click the vertical box and wrap with a size box, and then wrap the size box with a scale box. Then select the size box, and we'll do the width and height override. Width will be 320, and height will be 200. And then clear the palette search, and we're going to drag in an image onto the vertical box, and then we're going to drag a overlay onto the vertical box. And then we will rename the image to game area. And then rename the overlay to UI area. Then you can select the game area and wrap it with a size box. Then set the size to fill from auto. And then we're going to select both width and height overrides and do 320 by 145. And then we're going to select the color and opacity and bring the alpha down to 0. And make sure that the visibility drop-down is set to hidden. You can close the size box drop-down, and then we're going to right-click the UI area and wrap it with another size box. And then select width and height overrides again. And for the width, it will be 320, and the height will be 55. And this is the UI section. As you can see, the game area is at the top and the UI section is at the bottom. Now go to the palette and search for image and drag that under the UI area. And we're just going to stretch that horizontal and vertically. Next, we'll want to head over to the adventure mode blueprint, and we'll open up the event graph. And from event begin play, we're going to get the create widget node. And in the class section, we'll select our HUD. And from the owning player, you can drag that out and we'll get the player controller. And then after that, we will take the return value and say add to viewport and then compile and save. And so if we hit play, now you'll see that the UI section is down there. And then now we'll want to open the adventure character. And then we'll add a variable that will be called mouse over UI and make that a bool. And drag that in. And from that, we'll do a branch. So on the left mouse click, we want to check if the mouse is over the UI or not. If it's not, then we'll continue on with the functions. If it's true, it won't do anything. Back over in the HUD widget blueprints graph, right-click and look for the is hovered node. Connect that to a branch and connect that to the event tick. So now we know if the UI is being hovered over. Then we'll get the player pawn, and we'll cast to our adventure character, and we'll do that twice. Connect the true to the top and the false to the bottom one. And then from the adventure character pin, we will look for the mouse over UI bool, and we'll set that to true or false. So the bottom one will be false, and the top one will be set to true. And we can compile and save and test that out. And it looks like the character does not walk when you click the UI, so that is working perfectly. So we can remove the image now in the UI area, and we're ready to start adding buttons. So if you download the zip file in the description, you'll have a font file and then some images. And the images can go into a UI folder in the textures folder, and just make sure that they all have the Paper 2D texture settings applied. And the font file can just go in any font folder you want to make in the root folder. Next, we're going to create a new widget blueprint that we're going to call WBP_interaction. So if you open it up, go to the top right and switch it from fill screen to desired. And then we will drag in a scale box into the canvas panel. Then right-click the canvas panel and replace with the child. And then search for a size box and drag that under the scale box. And then select the size box, and we'll do the width and height overrides. And for the width, we'll do 320, and for the height, 9. Next, we'll search for the text, so you can clear the search, and you'll see text here under the common. And put that under the size box. And then we can just change the text to something temporary like walk to. That will probably be on there the most. And then for the color, we will type in, just to keep our color scheme going, replace the hex sRGB color to 7D652AFF. Now, under the font dropdown, switch the font to the pixel font that was provided and change the font size to 6. Then set the letter spacing to 50 and the justification to center. All right, that looks good. So you can compile and save that. And then back in the content browser, create a new widget blueprint that we'll call WBP_verbs. And then open that up. Switch from fill screen to desired again. Do the same things before, bring in the scale box, replace with child, then bring in a size box. And the size that we'll be looking for this one will be, the width will be 142 and the height will be 46. Next, search for a horizontal box and drag that under the size box. And then we'll rename it to verbs. Then we'll search for a vertical box and drag that under the verbs. And we'll rename this left verbs. And then up in the padding section, we'll change the right padding to be 1. And then search in the palette section for a button, and we'll drag that under left verbs. And if you select the button, you'll see under the appearance section, under style, we want to change the normal, hovered, and pressed with an image. So when you, in the draw as drop down, switch that from box to image in each of these. And then we will select for normal the give norm image. And then for the other two, we have the give selected images. And we could just rename this button to give and duplicate it 2 more times. And if you select the top 2, then head up in the padding section and change the padding on the bottom to 2. Now you can rename the other 2. So rename the second one to be open and rename the third one to be close. And then you can swap the images for both of these buttons. And I'll just speed this up real quick. Cool. So now duplicate the left verbs section twice, rename the middle one middle verbs, and rename the last one right verbs. And then rename the top right one use, the middle one push, and the bottom one pull. And replace those images too at your leisure. And then for the middle ones, the top one will be pick up, the middle one will be look at, and the bottom one will be talk to. And you can just change all of the images for each of these buttons. And remember that the normal style is going to be just the normal image, and then the hovered and pressed will both be the selected image. All right, now we're going to adjust the padding a little bit. So for the middle verbs, we're going to have a padding on the left of 1. And on the right verbs, we're going to add 1 on the left, but then remove the 1 on the right. So this is what it should look like at the end, and you can compile and save. And if you head over to the graph, you'll see the variables are all there for the buttons that we can use later. Cool, so you can close that and head back over to the HUD blueprint. And in here, we'll just fill in some stuff. So for the UI area, we'll need a background. So drag in an image, and we'll stretch that horizontally and vertically. Change the color to black. And then under the image that we put in, what we need is a vertical box first, because we want the interaction text to be at the top, and then at the bottom, we'll have the verbs and the inventory area. So drag in the vertical box, and we will stretch that horizontally and vertically. And under the vertical box, we'll drag in our interaction first. So this is under user created, our interaction blueprint. And then under that, we want another horizontal box, because this will stack the verbs in the inventory left to right. So first thing we want to drag under the horizontal box is the verbs. And we will set the right padding to 2 in preparation for the inventory. Speaking of inventory, let's make that now. So in the content browser, we will add another widget blueprint that we'll call WBP_inventory. And we'll open it up and we'll do all the things we did before in the intro. So we will add a scale box, drag it under the canvas panel, replace with child, bring in a size box under the scale box. We'll set the width override and the height override. So the width will be 174, the height will be 46. Switch it from fill screen to desired, and now we're in the right size. And then under the size box, we're going to add a horizontal box because we need 2 rows of inventory squares. Now search for vertical box and drag it under the horizontal box, and this will be where the arrows are. So we will say this will be called inventory arrows. And you can rename the horizontal box to inventory section. So under the inventory arrows, we need a vertical box. Now we're going to search for overlay. We're going to drag that under the inventory arrows. And you can rename this to up arrow. So we'll need 2 things under here. One is an image, and we'll rename the image to up arrow BG. And we can change the color to 120C00FF. But we can also open the color and we drag the color up to the top area and it will save it so we can reuse it later. And if we go back to the interaction blueprint, you can actually drag the color of the walkthrough text so we don't have to type that in again. So the second thing that we're going to drag in the up arrow section is a button. And you can set the normal style image to the up arrow normal. And it should resize it right. So let's change the background size to the same size, which is 14 by 22. And rename the up arrow button to up arrow button. And I guess we could rename the up arrow overlay to up arrow section and change the button name just to up arrow so it's easier. Now you can duplicate it, and we'll just call this down arrow section, and just replace everything with the down arrow. And be sure to change each draw as to image and go ahead and select the selected images for the hovered and pressed for both. Next, select the up arrow section and change the padding on the bottom to 2. Cool. The next part is fairly simple, so drag in a vertical box and drag it under where the inventory arrows is. And then we will rename it to inventory. And then search for a horizontal box and drag it into the inventory and rename it to top inventory row. And we'll duplicate that and we'll call the bottom one bottom inventory row. And then we'll search for an image for now, and we'll change the size to 38 by 22, and we'll change the color to the selected color we had earlier, the darker one that we saved. And we'll rename the image to top item 1 and duplicate it 3 more times. And then select the top 3 and change the padding on the right to 2. And then in the inventory arrow section, change the padding on the right to 2 also. And that should be spread out correctly. And then just rename each item to the corresponding number. And then do the same thing for the bottom. But I think a better name for this would be bottom item BG1, so that we can place a button over top of it later. Because really this is just kind of the background to where the image sprite will end up being later. So make sure you add the BG into all of the top items also. And then we will select all of the bottom item backgrounds, and we'll change the size to 38 by 22. Select the top 3, change the right padding to 2. And then select the bottom inventory row and change the padding on the top to 2. And then, of course, change the color of the background of the bottom images to the same color as the top. So now we have the layout that we need, but now we need to select every image that we placed and make sure the top variable is unchecked. So the only variables we have are the buttons. So if you compile and save and go to the graph, you'll see the only variables are the down and up arrows. And that's what we want right now. Cool. So you can close that and head back over to the HUD blueprint, and we'll just drag in the inventory to be under the verbs in the horizontal box. All right, let's compile and save and see what that looks like. If we hit play, it looks pretty good. The buttons all light up and you hover over them. We can walk around. If we click in the UI, it won't make us walk anywhere. Yeah, it looks pretty good. I think there's just one small thing to tweak. So if we go back over to the HUD, we'll see that there's no spacing on the left. So just select the verbs, and on the left padding, we'll just do 1. And that should center everything correctly. And yeah, it looks good now. All right, that does it for this video. Thank you so much for watching and powering through it. If you liked the video, please hit like, and also please subscribe. That'd be cool. And then you'll be notified when the next video is out. All right, thanks.